Hello guys, welcome to today's lesson. Just a short one. I want to help you guys understand how to interpret electric circuit questions. So, if you were to have this kind of a question in your exam, what you should understand is that firstly, current is flowing this way. That's the first thing. And then the next thing would be the question of where is this voltmeter measuring? Okay, this voltmeter is not measuring both branches. It's definitely not measuring both branches. Although the reading is going to be the same, but it's not measuring the top branch. Let me show you why. There's a voltage that's going to go this way, okay? And then there's voltage that's going to go that way. But for it to get there, it must pass through there, okay? Now, that's the voltage. You see at this point, that's the voltage that's being measured. But now, here's another important concept that if examined on and you don't know, you're probably going to get it wrong. What is voltage? We are told that voltage is potential difference. And this I learned from a past paper. Potential difference measures the voltage difference basically here and there. And it makes sense. If in this case we have an EMF of 12, what's going to happen is that we know that both branches are going to have 12 volts, okay? But if you were to sit down and ask yourself, how is that measured by the voltmeter? What happens is that you have 12 volts that's coming through there, okay? And then this resistor is going to use up some of that. And then that resistor is going to use up the rest of it. Because we know that in series, the voltage is shared between the two resistors. And then when we get here, we have 0. So basically, your voltage is 12 minus 0. Okay, that's why we say the voltage across that branch is 12 volts. It's the potential difference. The reason I'm telling you this is because I've come across a past paper where the voltmeter was connected here and there. So I'm not just making up stuff to confuse you. I'm trying to help you so that you know what you're talking about in your exam. So if the voltmeter was connected like this and you're asked what is the potential difference, basically it's the voltage that's passing through here and there. And then you're going to minus the two values, the bigger value minus the smaller value. That's the potential difference, okay? And another concept I want to explain using that paper is the fact that if we look at the voltage passing through there, okay, it's not the same as the one passing through there unless the resistance is the same, okay? So what's gonna happen is that the voltage that's measured here is the one that's going here. It's not the one here, okay? It's not the one going to R1. It's the one that's passing through the through this point, okay? Through this point over there, okay? Just the same as here, it's the voltage that's passing through that point, okay? That's important. Even here, this may have been 2V. So yeah, let me use values actually to explain what I'm saying. We know that both branches are going to be 12 volts, right? If this was 3V and this was 2V, what I know is that I know the question says they're identical, but for the purpose of explaining, please try and understand. If these were our values, okay, and now I know that in each branch it's 12 volts, the voltage passing through here is going to be 9V, the voltage passing through there is going to be 10V, okay, and I know that my potential difference is going to be 10 minus 9, which is 1V. That's my potential difference. We don't usually get asked this type of question, but I was just letting you know what's cooking, So here we have 12 volts and there we have 0 volts. It gives us our potential difference. Now another thing is that you should know that if, take for example here, if I added a branch now here, and I call this R5 RT, okay, because I wrote T, and I call this RX. Okay, what's going to happen to my effective resistance, which is basically my total resistance? It's going to decrease. When we add resistors in parallel, the voltage, the effective resistance decreases. Now, when I take this out, what would have happened to my effective resistance? It's going to increase. So if a question tells you maybe that switch S2 is opened, what happens to the current over there? You know that, okay, in opening this area up, what's going to happen is that my R is going to increase. I'm removing resistors that are in parallel. Okay, I'm removing a parallel branch, so resistance is going to decrease. Therefore, the current in the circuit is going to decrease. Okay, and I hope this makes sense to you. Another thing is, say for example, I had a resistor over here, R. Essentially, what I can do is I can treat this whole thing as one resistor, okay? And let's say, for example, just for example's sake, this was 2 ohms, okay? To know my total resistance, I would calculate using 1 over Rp the resistance of this area over here, the parallel branch, and then I find it maybe, let's say uh Rp after calculation is 3 ohm. Okay, from here uh it helps me to treat this as one resistor, because I can say, okay, this entire thing is 3 ohm. Now if I wanted to understand how the voltage is shared, I know that, okay, the voltage is going to be shared between 3 ohms and 2 ohm. What am I going to do? I know that, in my mind, I know that, okay, the more resistance, the more voltage is used up. So I'm already expecting that the voltage across the entire branch, or in each branch, should be higher than the voltage in the 2 ohm resistor. So I already have a picture in mind of what I'm looking for, and this can help me maybe if I need to calculate the voltage in the parallel branch, okay, by treating this thing as one resistor basically. And yeah, the next thing I want to do is ratios. I wanna try quickly explain how ratios work. Right now we're told that we have three identical bulbs, sorry. Okay, we have three identical bulbs. I'm gonna remove this for explanation. And if you had this case, what happens is that you're gonna have, this is X resistance, that's X resistance, that's X. I'm using X for all of them. Why? Because they are identical. Now what's happening here? Here we have 2x, okay, and there we have x in total. Now look at this. If they asked you what's happening, what happens to the voltage, we know that the voltage is not going to change. Both branches are going to get the same voltage. But now let's look at the current in each resistor. If we're looking at the current in each resistor, I know that that resistor and that resistor are basically going to fight for the 12 volts that comes here, okay, whereas this one is, it's using up the 12 volts alone, okay, and we know that for a constant resistance, more volts means more current, okay. So in this case we're going to have more current than in this case, because these two are sharing the voltage. So since they're equal, we're going to have 6V here, and we're also going to have 6V there. So you can see that it's not the same as in the first branch, although the bulbs are identical. So what I have now is, I have 12 is to 6 is to 1 is to 6, sorry, which is 2 is to 1 is to 1. And this can help you, especially I think in multiple choice, where you have these kinds of questions, that what is the ratio of the current, it's 2A is to 1A is to 1A. You can get what I'm saying? And that concludes the lesson for today. I hope this helps you, like it clears out some of the questions you have on electric circuits. And uh, best wishes for your prelims, guys. Push hard, study hard, and pray hard. And yeah, I hope God helps you all. Thank you for watching.